All right, welcome back. This is going to be factoring polynomials, kind of a part one, more of an intro kind of review from Algebra 1, but really important skill set to get down before Algebra 2. Once again, let me reiterate, this kind of short video series is really important just to like kind of give a good check of where you're at, where you're standing at. If you really want to get a head start on Algebra 2 and prep for your future coming classes, I really do recommend visiting Khan Academy, and the links that will be in the description down below. Definitely check those videos out and go through. But if you're just here for a light skim, this video series is perfect for you. And yeah, let's get right into it. So this part one of factoring polynomials is going to essentially go over two methods. First is going to be factoring with the greatest common factor, commonly also referred to as the GCF. And then we're going to have a factoring method two, which is going to be factoring polynomials that are a difference of squares. There's a couple more strategies or methods that will be in the final video, which is going to be part 4 of 4. And yeah, so without further ado, let's just get into basic overview of factoring. So factoring, this is one of my favorite definitions of factoring. Factoring is a polynomial. Factoring a polynomial means expressing it as a product of other polynomials. So essentially, factoring in a sense is trying to take a complex polynomial and reducing it and simplifying it into multiple polynomials, right? Multiplied together. That's because they're the product. And so basically, it's taking a complex polynomial, making it simple by making it a product of smaller, more simple, and less complex polynomials. All right, so let's observe this with the first way, commonly called factoring with the greatest common factor. This is the simplest factoring that you'll come across with in your kind of classes that you'll be coming across. And essentially, the goal here, right, is to find a common factor among all these three terms, right? So before we get into this whole polynomial, let's do a brief overview in a sense on like what a factor is, right? So like we can get the number 10, right? The number 10 is essentially going to be divided into two factors, right? 2 and 5, right? They're called factors because they play a factor, or they're a factor in, you know, of 10. So they multiply to each other to be 10, right? So we have 2 and 5. We can break down like another number, like 12, into like what? A 2 and like 6. And then we can break down 6 into something even smaller, where essentially the 6 kind of looks like this, where it's broken down into a 3 and a 2. And so this 2, pardon my handwriting. So then this 12 is going to be broken down into a 2, 2, and a 3. So with that said, let's get into this actual structure here. And we can, same thing with variables like an x. With numbers, we can break it down into multiple different factors. So essentially what we're going to be doing here, we can break this 4x cubed, right, into a 2, right, and another 2, and then we can also break it down into 3 x's, right? And then how we can break this 2x squared, just going to drag down here, we can break it into a 2 and 2 x's, right? All multiplied to each other, we'll get a 4x cubed, and then the second term, we're going to get it 2x squared, and then for 6x, we can break it down. We can break it down into a 2, a 3, and an x. My goodness. And wait, we can just break it down into an x right here. So with the greatest common factor, right, these are all factors for all these three unique terms that we have in this complex polynomial. And our goal with this greatest common factor is to essentially, right, find the biggest factor that's combined, that's common across all three of these terms. looking across the board, I'm going to observe that it's going to be a 2, right? In all three terms, we have a 2 that's present. And then we have an x, at most 1x, not 2 x's, because 6x won't satisfy because we only have 1x here. And then we only have 1 2 across all three. We can't do anything like 2 times 2 or 2 times 3. That's not a common factor. It is greater, but it's not common. So essentially, the greatest common factor here is going to be 2x. So knowing that, we've established that. Essentially, what we can do is take this, right? And we can type in it, we can bring it out and go to the bottom here and bring out 2x, right? Factor it out, and we can do a parentheses. And then basically we got to figure out what times 2x is going to give us our original term, 4x cubed. And this is going to be 2x squared, right? 2x times 2x squared is 4x cubed. And then we can move on to our next term. And then essentially it's going to be a minus x, right? Because we have 2x times a negative x. That's going to be minus 2x squared. And that's going to give us our middle term. And then finally, our final step, we can do a plus 3. This plus 3 times 2x is going to be 6x. And essentially what we've done here, right, we've taken this complex, 3-term polynomial, and we've simplified it by taking out this 2x, which is the greatest common factor. And then essentially we have, going back to the term, to the slide, right, essentially we've gotten a polynomial, we factored a polynomial and expressed it as a product of other polynomials, right? So we've got, this is more like a monomial, but basically it's the simplest way where we have, right, this 2x times a polynomial. So we've got a product of two separate terms that are both simpler versions of this 4x cubed minus 2x squared plus 6x. So with that said, that's going to be like the biggest way. It's not necessarily a problem you're going to come across in Algebra 2 where it's like, hey, factor with the greatest common factor. But what I most likely predict, especially going to Algebra 2, is you're going to come across these polynomials that are going to look like this. And you look at them, and right from the get-go, you're going to be able to be like, hey, all these terms are divisible by 2 or divisible by 3, 4, 5, etc. And you can simplify them because a lot of times, you'll get these polynomials and they'll be slightly more complex than you're used to. And then you're going to realize, hey, is there an opportunity to simplify this complex polynomial before I try my other methods, right? Your number one method here is going to be greatest common factor. What this is going to do for you is essentially if you get, a term like this that you see here, you're going to be able to simplify it, you're going to reduce the numbers, and you can take out that 2x or that greatest common factor, set it to the side, worry about it later. And it's going to, I guarantee you, it's going to simplify your problem solving from there on out. Always the number one step to look at for. With practice over time, you'll be able to recognize these situations and save yourself a lot of pain and trouble in the future. So with that said, we're going to go into factoring method number 2. These kind of methods from here on out are more kind of like situations that you'll come across. And a difference of squares is a very good situation to come across that will make your factoring a lot easier and a lot simpler and a lot faster. So a good example that I'm going to create here is going to be x squared minus 9. And what you'll notice here very soon is that this is indeed a difference of squares, not necessarily with 9 at play, but with x and the number 3. I can draw in parentheses here. It'll probably be more simple to view it like this. But essentially, right, we have x, right, squared minus 3 squared. So x and 3, they're both squared. So, and then what's critical is it must be a difference. It won't work for an addition of squares, but primarily a difference. And I'll go into why that is necessarily. So let's expand out. Let's go to a new tab here, and let's focus in. Okay, So the biggest thing is the reason why difference of square works. Let's rewrite x squared minus 9 up here. And then let's look at an algebraic term actually over here and kind of break it down. So if we have terms, let's say we hypothetically have a minus b and then times a plus b, right? And let's multiply this out, right? Using FOIL method. And essentially, right, we can multiply the first terms together and we're going to get a squared. And then, well, let's use FOIL. Then we get a, in the writing again, we get a minus BA. And then we can go ahead and then we'll also get a plus BA. And then at the end, we'll get a minus b squared. Okay, and then you'll notice really quickly that these two middle terms, they cancel out, right? And then at the end, right, we're gonna get a squared minus b squared. And you'll notice that once again, right, this is the difference of squares. And factoring, we're kind of going backwards, like a lot of people say. And so essentially, right, with these terms, we can kind of relate a and b here to our problem that we're going to try to solve, which is x squared minus 9. And the biggest way we're going to do this, right, well, how we want to do is, you know what, I think I'll make an additional slide perhaps. We'll see how I can do this. Hold on. All right, actually, we'll just use this blank spot. But how we can do this, right, where we have this, we want to replicate this a minus b situation, is we can realize, right, a is the first kind of factor that goes into like the squares, and then b is the second one, and it's emulated with x and not 9, but 3. So we can play this out where we get like an x minus 3 and an x plus 3. And very soon you'll be able to realize how this, right, will translate into our difference of squares, right? We do FOIL, multiply it out, x squared minus 3x plus 3x and minus 9. Once again, you'll notice the middle terms cancel out, and we eventually get our x squared minus 9. And essentially, that's how you do that. You're going to tackle these difference of squares questions. So let's create a new one. Let's say we have x squared minus 25. What we can do is kind of realize, okay, we want to get into a term that we kind of understand, and it's going to be a difference of squares, right? So first things first, right? We know this is x is our first one, and then here our second one is going to be what? Not 25, it's actually going to be 5, right? And 5 is going to be our other number in here. So it's difference of these two squares, and you can factor this out into an x plus 5 and an x minus 5. So essentially, this kind of method of solving is kind of showing you a pattern, and that simplifies it, and can make your factoring go a lot faster, especially if you see this pattern in a problem where it's just, once again, a difference of squares, right? In this case, x squared minus 25 is a difference of squares where it looks like x squared minus 5 squared, right? Keep in mind, it must be a difference, and it must be a difference of squares. So it has to be x something squared and 5 squared. I know a lot of students can get really confused when they try to factor it into this x plus 5 times this x minus 5 form, and they'll mix it up. They'll maybe like, hey, is it x squared? Is it x, or is it like x minus 25? Just keep in mind, it might not necessarily be 25, because you got to dumb it down into a squared format where it's like 5 squared, and then you're going to be able to get your factoring. So let's probably move down a little. Trying to figure out how to create a new blank slide. Let's actually delete this. But yeah, so just to reiterate my point, this is just the last concept of this video that we'll be going over. So I really want to just hone it down, make sure that you guys fully get it. We can get a difference of squares in a more complex format per se. we could get, for example, we could get 4x to the power of 4 minus, right, because this is a difference of squares, minus, let's say, 121, right? And then, so this might be a little more confusing. You don't necessarily see a square right at the beginning with your variable, but still very doable, right? If we're looking for a difference of squares pattern, let's try to convert it into a form that we're familiar with. And right away, I can see this 121 is 11 squared, right? And we can put this minus sign in front. The beginning part seems a little more tricky, something that we haven't really touched upon in this video, but we can simplify it into a squared form very easily. And I'm going to venture, and I'm going to say 2x squared. See where am I going to say 2x squared over here, and then that itself is going to be squared as well. So if you multiply 2x squared and square that, you're going to get 4x squared. And then essentially how this difference of squares factored is going to look like is we're going to get 2x squared minus 11 times 2x squared plus 11, right? And then essentially how we can do this, let's verify this, right? Let's do a double check. It's always good to double check, especially when you're doing these kind of problems at the beginning. And we can kind of multiply it out, right? We'll start with this, and then we'll go down, and let's FOIL it out, right? So at the very beginning, we're going to get 2x squared times 2x squared. So what's that going to give us? It's going to be 4x to the power of 4. And then we're going to continue, and we're going to then do negative 11 times what, 2x squared, right? So we're going to get, in a sense, negative 22x squared, right? And then after that, we're also going to get 2x squared times positive 11, right? So then we're going to get a 22x squared. And then finally, we get our last steps where it's negative 11 times 11, and we're going to get a negative 121. Once again, these middle terms cancel out, right? So they turn into 0, non-existent, and then we can simplify our final form to 4x to the power of 4 minus 121, and we're back to where we started. Everything checks out, and we're able to successfully factor this polynomial, which shows the pattern of difference of squares. Hopefully that made sense. There will be approximately 2-3 perhaps practice problems on this concept. We'll also play into the GCF, and perhaps we'll mix it up, do a little challenge problem at the very end for this video's practice problem, where it's going to be a combination of the factoring with the GCF to eventually get to a difference of squares problem that we can eventually solve. That's an extra challenge problem. Don't worry if you don't get that, but I am just warning you guys, I'm going to combine these two methods for a problem for this video. Hopefully that makes sense, but once again, this is just a quick overview, a quick scan, just to see where you're at, kind of review from Algebra 1, or perhaps good intro into Algebra 2. But once again, if nothing here makes sense or something doesn't make sense, definitely check out Khan Academy. Really good resources right there. It's really good for self-directed learning, and really important to get familiar with this resource, especially going through the school year. You can always go back and double check and follow along your teacher or lecture material. Definitely recommend Khan Academy content over this kind of content that I'm creating. Basically, I'm just trying to give a quick overview, quick scan, quick brief crash course, which and yeah, but that's it. That's factoring part 1. I'll see you guys in the next video for part 2. And yeah, have a good one.